We're talking about how to secure the networking for your application in AWS. In this case, we're simplifying into a 3-tier application. We've already added all of the main networking elements. We've got our gateways, the internet gateway, the virtual private gateway. We've got subnets, both public and private, spread across multiple availability zones. We've added our route tables to give the correct subnets access to the correct assets. We've also talked about security groups and the fact that every instance has security groups around them that define traffic coming in by port, protocol, and IP range. The default behavior for security groups is to deny all inbound traffic, so explicit rules have to be added to accept any traffic coming between them. It's not the only traffic regulator inside your VPC. Subnets can have optional network access control lists, NACLs, NACLs, applied to each individual subnet that also can filter based on IP range, port, and protocol. It feels redundant, and for a lot of our networking needs, it is. However, the way that NACLs operate are different than the way security groups operate in the fact that NACLs are stateless, security groups are stateful. In other words, any packet that is coming from an instance and is allowed out of a security group will always be allowed return traffic even if there is no rule for inbound traffic that would have allowed communication from that return source instance. This idea of being able to remember return traffic is what separates it from the NACL, whereas the NACL has an inbound rule set and an outbound rule set, and each one must be evaluated as part of any round-trip process. Well, let's kind of give an example and see how this plays out. So let's pretend that we have a packet that is initiating from this particular instance, and it wants to communicate with this particular instance. So it's going to pass through the security group on instance 1, the NACL for public subnet 1, the NACL for private subnet 1, and the security group around instance number 2. Well, here's the evaluation rules. We begin with the packet attempting to exit the security group around the first instance. The default rule set is to allow all exit traffic. However, this rule set could have been changed, so the packet is inspected to make sure that it's targeting a properly authorized port, protocol, and IP range. In our scenario, it's allowed, so the packet is allowed to exit its home instance, at which point it reaches the subnet boundary for public subnet 1. This is passport control. Is your packet allowed to exit this instance? Are you going to a safe location? We check its target. We make sure that it's authorized port, protocol, IP. Yes, it's authorized. We'll go ahead and allow you to leave the country, to leave your subnet, take your journey across to the next area. At which point, passport control. I am now entering into private subnet 1. Explicitly, there must be a line saying port, protocol, IP address. Is it authorized? Default behavior is allow all, but again, there may be a block. Our scenario, no block. Packet passes through passport control and reaches the instance. Once again, port, protocol, IP address. It's a stateful check, but we're looking to see, does this packet in fact have, are you on the invite list? Are you allowed to come in? The explicit rule is deny all traffic. This is the most likely culprit if a packet's not getting in as to why you're being blocked. You must whitelist it. In our case it is. Packet enters the instance and does whatever action it needs in the instance. Action is complete. Party's over. Time to go home. Time to get the response traffic out. In this case, as I leave the party, as I leave the house, the doorman recognizes me. It's a stateful firewall. It doesn't check to see if I'm allowed to go home. It just lets me out of the building, waves goodbye, says, have a nice day. I leave, and then I get to the subnet boundaries, and it's passport control. They don't care if you were allowed in. They're going to check again to see if the return traffic is allowed. They don't even know it's return traffic. All they know is port, protocol, IP. In this case, no blocks. Default behaviors allow all. Traffic leaves. Passport control on the home subnet, once again, port, protocol, IP address. Is it allowed? Yes, it's allowed. It's stateless. There's no memory. I then get to the security group of my originating instance, and my home doorman recognized that I was allowed out the door in the first place. It doesn't check to see if anything's changed coming home. I am allowed to return home, and the packet completes the process. At this point, we have now managed those differences. About this time, many of my students on watching this say, oh my goodness, because passport control checked me both coming and going, it would seem to me that the security functions of my subnet network access control lists are the more powerful function. I should use those exclusively. Before you let that get into your head, you need to ask yourself, how many subnet boundaries does instance 1 to instance 3 cover when they talk to each other? 0. If you are in the same subnet, there are no NACLs that get negotiated. NACLs are only negotiated if you are crossing subnet boundaries. It doesn't matter if it's across AZ or not. I do not negotiate NACLs when I'm inside a subnet, but I always negotiate security groups, and every instance has them. So your default behavior when rule writing should be put all of your rules in a security group and use NACLs to either double up, support, or override behavior that is otherwise declared at the security group level. That's going to get you one of many controls needed to protect your assets inside the AWS VPC.